We can begin, I suppose. Thank you, everybody, to be here. Thank you to the organization to invite me. It's a pleasure. And the goal of this presentation is to introduce the Rust language, but actually I should have choose another title actually, because there are hundreds of languages and there is advantages or not. And I think you can be a web developer, you can be working on hardware, everything. There is an interest to consider for some tasks to use Rust. And I'm going to try to explain why. Actually, the philosophy of Rust, it's the reason of the name Rust. Rust, you know, it's a rust metal. I don't know in Armenian. How can I say Rust in Armenian? Yeah, okay. And it's this philosophy, it's this mindset actually. No innovation in the language. We put in the language only stuff which are approved by the history, by the experience. So, for example, object-oriented programming was something relevant because it exists for a long time, and we have proofs of solidity of the concept, so it's in Rust. But do not look for new concept in Rust because it doesn't exist. You can find lambda expression, you can find oriented objects, stuff like that, concept in computing science, but nothing new. And Mozilla Research launched that project, the creation of this language, something like, I'm not sure actually, but something 25 or 2010 in these years, and with the intention to have something reliable, especially for tasks where they got regularly problems. And there are two main topics in computing where you got problem. It's memory management and concurrency. When you begin to work with multi-threading, it's complicated. Rust is a compiling language. There are not too much compiling languages, actually. There is mainly C++, actually. And the problem with this kind of issue, memory management and concurrency, thread concurrencies, it's you got the problem at runtime, not at compiling. The compiling C++ is okay. The memory management seems okay. You are able to allocate memory, to put data inside, to disallocate your memory. Everything seems fine. You run your program, everything is fine, but in some situation, a day, you will get a trouble with that at runtime. And the intention, the philosophy of Rust was to try to not predict, but to anticipate this kind of problem and to identify this problem at compiling. I'm going to focus mainly on the memory management, not especially about concurrency, but it's the two strengths of the language to get something reliable in terms of memory management and concurrency. So, as I explained, the spirit of Rust is like Rust in Armenian. It's integrate only very strong concept, no innovation. So you can find some stuff you know from other languages, functional languages. So we evaluate and we do not destruct variables like in Lisp or a lot of language like that. Actors model is from is much for concurrency and multi-threading. Procedural is something very strong, and So it's also a procedural language and object-oriented. So you have multi-paradigm. You cannot say it's an object-oriented language because it's, yeah?
The actor model, does it compute it? I mean, is message passing a thing or is it a library? And Rust just supports it?
Yes, it's the second thing you said. It's create a language able to easily support some library based on models actors. Yeah, yeah, excellent remark actually. So yes, the goal of guys from Mozilla Foundation was to try to avoid problem at runtime. You can have a reliable code able to be compiled, no problem at compilation, and 80% of time there is no problem, and sometimes with the configuration, with some data, with some big values, you will get a runtime error. So the idea is to try to prevent that during the compiling time and not at the runtime time, if I can say like that. In C++, there is no protection. Actually, you are in charge as a programmer, you are in charge of the memory you allocate. You put what you want inside, and you are in charge of the memory you disallocate. You are really in charge of C++, and nothing helps you from the language. And yeah, and in main languages, you have some stuff like garbage collector to do that for you, and you don't have this kind of troubles. But when you have a garbage collector, it's difficult to have something very very quick, because you delegate this memory management to stuff you don't know anything, and it's difficult to have something reliable and mainly quick. Just a small reminder. So when I talk about memory management, I talk about what we do with stack and heap. So we are going to put some stuff on the stack, like in every languages, and in languages like C++ and Rust, we are going to dynamically allocate memory to put stuff inside. It's in the heap. And we have quite frequently a problem about the type safety. For example, if I have a big number, a big integer, and I multiply by 2 this big integer in C++, it's supposed to be a big integer, but it will be too much comparing to the definition of a big integer. So it should compile, but you probably will get a day, you will get something bad at runtime. And it happens because actually the difference between compiling and runtime is the difference between do some stuff, programming in front of your computer, and real life. This piece of code I used for autonomous vehicles, for stuff flying, etc. So the runtime it's real life. I come from France, and I did some studies in computing in France. And what I mentioned here, Ariane flight V88 in June '96, was quite traumatic for computer scientists in France because it was the third version of Ariane 5. Ariane is the rocket program to send satellites in space, and it's launched from Kourou in Guyane, in French Guyane. And it was the end of the Ariane 4 program, and it was the first one with Ariane 5. And it was a crash, actually. There was a crash after a few minutes. It was something like, I don't know, 200 or 300 millions of euros, which disappears like that. And after investigation, the reason of that was a memory overflow, actually, because some code from Ariane 4 was kept in Ariane 5, and there was, at the moment, some data put in memory which was not really allocated. And the type used for this data was not relevant. So the reason is computing. The reason is something able to compile. The language was ADA, I don't know in English, ADA, ADA, and at this time it was already oriented object. It was ADA 95, so it was object. It was used for this spaceship program. And so it's an example. As soon as you begin to have studies in computing in France, you hear this story quite frequently. So managing problem at runtime, preventing problem at runtime, it can be save satellites, but actually it can save lives. So because consequences are real. It's not like a program which doesn't compile on your machine. It's you are in the real life. It depends the goal of your program, but it can have very bad consequences. So it's globally what I explained. It's globally the philosophy of Rust, trying to avoid every problem at runtime. Do not use any innovation. Use very solid concept from the history of computing science. It gave the name of Rust to Rust, actually. Some example of piece of software coded with Rust. So there is Servo, there is Cargo. Cargo we will see much later. And in famous stuff, we have Discord. And we have some cryptos, some popular crypto. I read just before that the new kernel of Windows 11 will be coded in with Rust. So it was a quick news, so I don't know details, but we can imagine that as soon as you want speed and reliability, it's a choice which is gonna to be done quite frequently, more and more frequently. Why it is interesting? There is plenty of languages. Why it is interesting to think about use Rust in your job? For example, we have quite frequently microservices architecture with a microservice. It depends the context, etc. But you can be quite free with your technical choice, actually. And only about question of speed and energy consumption, the difference is huge. I don't speak about reliability and crash and rocket crash, only speed and energy. Now from everywhere on the planet, the creation of energy is quite important. And as you can see, I'm not sure you can see, but it's from a study, the only study really relevant done in 2019 to evaluate with the same machine the speed of program, the energy used by the program, and the memory used to answer this the question. So they did something like 20 programs. For each program, they used the optimized algorithm in Python, in Java, in C#, etc. And they used the same machine to run every program. So 20 languages multiply 20 programs, more or less. And they did comparison. And so the best is still C, language C, in terms of time and energy. And everything is based on C. So Rust is really good. Rust is 1.03, 1.04. But for example, a popular language like Python in terms of energy is, I cannot see really clearly. I remember it. I wrote there. In terms of I did a mistake, speed, time, memory. You have to read. The first one is energy, it's not speed. Sorry for that. It's energy. Python use 75 times energy comparing to Rust, comparing to C. And it's not low, actually. I did a small study about that. And about this study. And for example, if you decide to program a microservice and you have choice between C or Rust or with Python, there are some microservices coded in Python. The difference based on one of the problem, binary trees, one of these programs used in this study, the difference is quite huge. It represents the consumption of energy of 1,000 houses in France. So every day. Every day, it's the difference for one program, for one microservice, and you have sort of architecture with dozens or 100 microservices. So it can be specifically now in our times a good idea to think about that, to try to evaluate the consumption of energy of your microservice and to determine if you are quite free, it can be a good option to choose Rust. But you can answer, why Rust? Why not C? C is the best, but Rust is almost equivalent to C. But with Rust, you have the reliability. You have the management of memory. With C, you have nothing. You cannot prevent anything. Just to explain some stuff about the language itself. So there is a tool, Cargo, which is able to do anything you need. So everything is with Cargo. So Cargo here is, for example, this command line is for create a new project. And you're going to, perhaps, I'm not sure. It's small, perhaps, I don't know. It creates my project. So where it is here. And it's an empty project. So you have the possibility to create a library, a crate in Rust, or an executable. Here it's an executable. So you have a main with a function main, a bit like in C, C++. And you have a git ignore. Well, it's not so useful, but that's cool. And you have the cargo.toml. It's more or less like a requirements.txt in Python. So you have some data about your project here. And here, if you add some external libraries, you will have the name of the library and the version of the library. And that's all. Yeah.
How does the garbage collector work?
There is no garbage collector in Rust. Yeah, absolutely. Yeah, there is no. What's your favorite language, perhaps? Yeah, I can elaborate a bit.
TypeScript, let's say.
Oh yes, okay, TypeScript. Yeah.
And you can just type cargo garbage collect.
Actually, cargo is a command line. It's probably my fault. I was not clear. So cargo is a command line. Is a command line tool able to do everything you want in Rust. So create your new project. For example, to create a new library, to clean your project, to build your project, so to compile.
It's a package manager, basically.
Yeah, exactly. It's a package manager and a bit more because you can do you have access to the compilation and even the execution of unit tests and
like
sorry.
Like CMake.
Yeah. Much user friendly actually.
Yeah.
And you have the notion of release debug like in C# or C++ also. And yes, about garbage collector is in language like Java, like C#. So you delegate the responsibility to manage memory to the language. You don't want to know what's happened. In C#, if you allocate you have objects, you have instance of objects, you do that, and you don't care how it is disallocated. It's the job of a garbage collector. But it's not totally optimized. The language tries to have something efficient, but it's not optimized. Sometimes it's going to, in C#, for example, is going to disallocate memory, perhaps a bit late. It could have been a bit early, for example. And for example, in C#, they needed to, for example, to access very rapidly to database. So they decided to have non-managed tag in your C# code. You have the possibility to put C++ to have directly access to database without control, because garbage collector for this kind of languages is being on a virtual machine, like in Java, like in C#. The virtual machine in C# is the .NET framework, basically, and there is a first compiling, but it's not really compiling, into an intermediate language. So in Rust is like C++, but you have help, you have security. You are in charge of the management of memory, but you have a lot of security. And the security is, if it's not right, you're going to get a compiling error. So you cannot have an executable. You have to fix that. But it's for your health, the health of your code. So, just a word about the syntax, but the syntax is not the main topic today, but the syntax is a bit, I think that can be something you met plenty of times in other language. So Rust, it's a bit similar to C, C++. There are some, for loops, things like that, it's very similar to JavaScript and to C# also. So there is no strange things, no syntax very specific to Rust. The cargo.toml, for example, we installed the chrono library, and we will have that in our cargo.toml, a bit like in requirements.txt. To install an external library, it should be after, it's here. You go to crates.io, the main place. It's where you can find every external library, and if you want to do something with OpenStreetMap, for example, you look for, and you have some stuff, API, etc. And to install it, you only have to copy that, cargo add, and the name of the library. And when you do that, you will have a new line in your cargo.toml file. So, for example, in C++, and it's especially the case in languages like C#, for example, you don't care exactly if it's mutable or not, if the variable is mutable or not. Mutable and immutable, do you want a reminder, or that's okay?
We know.
Yeah, you want?
I'm saying we know.
Okay. So, and there is sometimes the programmer is going to code without paying attention about is it mutable or not, and it's compiling, there is no problem. But you can get some ambiguities between what you had in mind and what is going to happen in the memory. You can have some troubles because of that, and trouble only during the runtime. So in Rust, everything is explicit. You know exactly what you do. And you have the mute keyword for that. And you decide that this variable, the first one, you can precise explicitly the type of your variable, but you cannot, it's not an obligation, because here he is going to understand that 5 is an integer, so the a will be an integer variable. And we decide it is mutable. So we can change the address in memory, what there is behind the address in memory. B is not mutable because I don't use the keyword mute. After that, I have a const like in C#, C++, a lot of languages. It's not supposed to change afterwards, but it's a bit specific in comparison of something immutable. So as you can see at this step, everything is explicit. You know exactly, you can figure out exactly if the address pointing this variable will be changing or not.
Sorry, but can I ask a question? On the first line, let mute a equals 5. Isn't a like by value? It's not a reference. So how?
No, it's not a variable.
So it's not by value, so it holds a reference.
Yes, but here it's typically in this example actually these values will be on stack. It will be much relevant to take an example with something in the heap with object, instance of object, but I thought that it was a bit confusing. So it's you can have mutable or immutable in stack and in heap indifferently.
But mutable in this case means that A can point to a different address, right?
Or you can have directly the value in the stack.
Yeah.
Yeah, it's not really my point actually. My point is to show you this line. This line here, you're going to get an error at compiling. And actually,
C is a constant.
yeah, C is constant, but here B is not mutable, and you get an error also, because you try to change the value of B. You try to change the value
But
of
you
B.
change the value of B, not the address of B. So I don't understand what's the difference between const and not, or B not being mutable in this case.
Forget const. Just focus on B. B is not mutable. It's a value in the stack. It's something in the stack, stored in the stack, and we try to change it. In every languages, there is no problem. You can do that. And this behavior, you can have the same. You have the same in the heap. If it's an object and I decided behind this address in the heap, I decide it's mute or not, you can get or not some error of compiling. But error of compiling is really good because it's your protection. It prevents you to get some strange, non-deterministic runtime error a day and a rocket crash in the sky. If you get that, it's super because you see here everything is in the stack, so we don't think about allocation and heap, but it's exactly the same. The difference is the value behind your address is mute or not, is mutable or not, is the space is mutable or not, and here is the value in the stack is unchangeable or not.
So basically, Rust has like a built-in static analysis tool that's like that detects, prevents runtime.
Yes, he tried to figure out, to infer what it could happen. I'm not a specialist about the compiler of Rust, but he tried to do that.
Yeah, I heard that.
Yeah.
Basically that.
And for example, in C#, if you write string A equal Barcamp between quotes, it's totally implicit. Actually, it's immutable. It's immutable if you concatenate my string variable with 2023. It's not a concatenation in memory. It's a copy of the first and the concatenation with 2023.
It just points to a new value.
Yeah, but in the psychology of the programmer, there is nothing. In your mind, you see you know or not, but you program if it was a real concatenation in memory. It's not the case. The memory occupied is twice actually, something like twice, and at every change on your string, you're going to have a copy. So it's a problem sometimes. For example, if you have all memory you want, that's okay, but it's something on an autonomous device. You don't have too much memory, so you have to take care about that. And it's not so simple to program that in C#, for example, because you have to use directly the address of your string, actually. And the second problem is you don't think about that. So you think everything is okay. There is so with this kind of programming, you think quite always a bit about memory. And when you don't, the compiler say, yeah, you should think about the memory.
Can I ask a question?
Yeah.
Distraction. What's the difference between the const and the immutable thing? I want to use it.
By the timeline, constants come back.
I don't understand that. Can you elaborate?
I try to find structural difference. I think there is one. Const is a keyword. And I think we're going to take an example in heap, not in the stack, okay? And when you have const, imagine you have an instance of a class or struct in Rust, but a class Barcamp, yeah. And const is going to frozen this address. The result is the same, but it's not exactly the same than to say it is immutable. I agree the result is the same, even in my example. But it's not exact. Const is much like a lock, I think. I don't use so much const. I'm not a fan about const. But even in other languages, because const for me, it's okay with when you use pi 3.1 for etc. But it's provided by external libraries, so you do not really need to have const in your code. Actually, usually.
One more question: are these both of them are keywords and they are provided by the language? Okay.
Yeah. Yes. Yeah. Another concept, and it's related to reference. It's ownership and borrowership. In C++, for example, you have your instance, and there is no notion of property, and you have reference on that, and possibly a second reference, and actually
unless you use smart pointers.
Yeah, well, with pointers is equal, actually, but you don't pay attention about the mess, the possible mess you can get in memory. So to avoid that, they invented the concept of ownership. Every piece of memory is going to have an owner, someone possessing this memory, this variable, actually. Owner it's a bit figurative. It can be a variable, it can be an object, it can be a function, it can be a data. I'm going to have an example about that. For example, here, in terms of syntax, I don't need to explain what it is. We have a vector. You see it's quite simple to understand. And I have a mutable vector. A here is the owner of the vector. And it is mutable. So I have the possibility to give to another variable because it's mutable. And there is only one owner at a time. You cannot have two owners. Only one owner.
Possible to have like multiple variables pointing the same.
No, it's not possible. Only one owner. You're going to get a compiling error if you do that. There are strategies to avoid that. And here, you see, I try to push a new value in this vector, on A is still not the owner, so you're going to have an error compiling on this line. Here. Here. Okay, we suppose we comment this line. Here we call this function take ownership B. Here we have a passage by value in this function. So here this simple passage of value give the property to this function. Take ownership is the new owner of the vector. And after that, I try to push another value in the vector, and I have again error compiling because the new owner is this function. It appears like that. The first time I saw that, I thought these guys are totally crazy. It's creating troubles for yourself. Actually, there is no, and afterwards you understand the interest of that, because everything is on control, and it's like a discipline actually, and you avoid runtime error with that, but you get quite a lot frequently compiling error. The compiler is very explicit, so it's really quick to code. It's not difficult. Oh yes, who is the owner? You read the compiler message, and it's quite quick. Ah yeah, you forgot mute here. Frequently is able to suggest you some stuff. If you really try to do that with this variable, I suggest you put a mute at this line extra.
So how do you get the ownership back to B after?
In this example, I cannot answer immediately. It's a rhetoric example, clearly.
Don't we just return it? V?
I'm not sure. Actually, I'm not sure.
So after the scope of the take ownership function ends, the B variable is automatically returned. The ownership of the B variable is returned to the author scope. So let's say take ownership took the ownership of function of the B variable, and when the function ends, it automatically returns the ownership of B.
No, it doesn't return. In my example, I mean, here, after here,
yeah,
it's
here
this function
yeah.
which has the property.
Yeah, here it moves into the function, and it never can be accessed after the call.
Yeah.
Yeah.
Yeah. And it's a bit psychological, but when you code, perhaps it's the same for you. Usually, when I got problems, not in Rust, but in other languages, sometimes at the end of week, you have something bad. You do not have any hesitation to create a temporary variable to fix that. You want compiling, okay, to push that to GitHub, and that's all. And it's to avoid that, because sometimes you do some choice. Apparently it works, but it can have quite horrific consequences at runtime. It's the reason of ownership and borrowship. We have the notion of reference, like in C++, immutable reference. The reference itself is mutable or not. And for a piece of memory, if I can say like that, you can have only immutable reference or only mutable reference. I can go quite quickly on the next. I wanted to present some stuff about its concept you met in other languages, capability to filter stuff. I show you what I'm going to present in a few minutes. Notion of threat in Rust. It's clearly an equivalence of C++ abstract class. So basically, an interface is not exactly an abstract class, but between us we can say it's the same. So there is this notion because it's a strong notion existing for decades now, very useful. So they put that in the language. The notion of closure also. There was a presentation this afternoon about a language named Closure. I don't know if there is a connection between the. I couldn't see, but there is a connection with this concept. This concept is clearly to have lambda expression and this kind of functional programming in Rust. Like a bit LinkQ, the feeling I had when I learned that, it's a bit like LinkQ in C#, in my understanding. So capability to have evaluation and to write expression quite integrated and quite powerful. Questions?
Yeah.
Yeah.
Going back to the comparison chart that you showed earlier.
Yes.
So I think it would be more accurate to compare Rust to C++ rather than plain C or Python, because it's also touted as its successor. And as such,
Python in terms of speed and energy consumption is powerful. And C, C++, and Rust, C is a bit better, but it's the same. Yes. Yeah. For example, energy, C 100. It's the reference 100. Rust, it's 1.03. It's
so compared to C++, it's on the third.
C++ is 1.34. It begins to be a bit bad, but if you go in, for example, Haskell is 3. It's the top 10. Yeah.
The question is, how does Rust get that marginal performance benefit compared to C++? Is it because of less indirection and abstraction? I don't know, because the borrow checker seems like it's more complicated than the pointers in C++. I'm not so.
I'm not sure I should think about that. Perhaps my first answer is perhaps the answer is different for energy, time, and usage memory. That's possible. But for energy, I'm not sure. Yeah, it's the same for. I'm definitely not sure, but I think it's different to improve a language. Like C++, we have a new version now, and Rust, they got the opportunity to write something from a blank page. So perhaps there are some constraints which give some difficulties to improve the C++ language with this target, because at the beginning of C++, it was not really a topic. The energy consumption, for example, it was definitely not a topic. And Rust has something like 10 or 12 years now, so it's quite recent. And it's if you have a very nice house that you have to adapt in a goal, in particular goal, it's much difficult to end up this same goal when you build the house from the beginning. But it's intuition. I'm absolutely not sure it is relevant I'm going to think about that, and if you leave me your details, I can send you an answer. But yeah, not tomorrow. Yeah, very interesting question. Yeah.
Is there similar things like dynamic polymorphism in C++? Something similar here?
Between Rust and C++?
So we have dynamic polymorphism in C++, but do we have something similar in Rust?
Yes, we have. Yeah, we have something. There is also a keyword for that. Useful for that. Here, for example, I can do rapidly this in 1 minute, for example. I can do this example. And it's with this notion of tray. Here I define a tray, so interface, abstract class, whatever. So inside I have a function able to, a prototype of function able to supposedly calculate an area, and to the return value is a float on 64 bits. Here I have a struct. It's basically a class, but kind of struct. Struct in C++, you have something contiguous in memory. It's not, I'm not sure it is the case here. So you can get that like a class.
Struct and class is the same thing in C++.
Not exactly, actually.
No, it is the same. You can look it up. It's just on C, struct is continuous.
Yeah.
Yeah, but for portability reasons, they left the keywords.
Yeah.
But it's basically.
Difference is perhaps the visibility of attributes.
Yeah,
default visibility,
Yeah,
probably. It's a long time ago, but I think, yeah, perhaps is that the difference. It is that. So we have this class, circle, with an attribute, radius is a float. And I'm going to have an implementation of the tray for circle. And I'm able to have this function calculating the area. And here there is the dynamic, it is what I get from your question. It can be circle, but it can be the struct rectangle, it can be the struct point, it can be the struct very weird polygon. And here, dynamically, I don't know the type when we call this print area function. So to specify that, we use the din or din, I don't know, din keyword to have that. And it's not like templates in C++. It's really dynamically, you have the resolution dynamically. And but it is checked during the compiling. The execution is dynamic, but the coherence of your code is checked during the compiling. It's not exactly like generate tons of different arrays like templates in C++. And to be ready at runtime. It's a big difference to have, yes, I generated something for circle somewhere, so the program is able to rematch everything. Okay, 1 minute. Time over. Okay, thank you very much. Thank you.